In this tutorial, we'll learn about the effect of drag on terminal velocity using skydiving activity, which is the parachute. When a skydiver jumps from a plane at a high altitude, she will accelerate for a time and eventually reach terminal velocity. At terminal velocity, drag and weight are balanced forces, as we said in a previous tutorial. Typically, this will be between 150 and 200 km per hour. When she opens her parachute, this will cause a sudden increase in the drag force. At this velocity, around 200 km per hour, the drag force of the parachute is greater than the weight of the skydiver. This means that the unbalanced force acting on the parachutist acts upwards and for a while. She will decelerate as she slows down, the size of the drag force decreases, and eventually a new terminal velocity is reached. Obviously, the new terminal velocity depends on the design of the parachute, but it must be slow enough to allow the parachutist to land safely. Now let's see figure 3.16 that shows a velocity time graph for a freefall parachutist. The graph shows that the velocity increases till it reaches the terminal velocity, and suddenly it decreases again to the point where the velocity starts to decrease. This implies that the parachute was opened. After the decrease, it reaches a new terminal velocity. Now to get the freefall terminal velocity or the new terminal velocity, we just have to extend the line so they could meet the y-axis, and the intersection will be the value we're looking for. Now let's watch this video by pressing on the hotspot icon. Here we have a skydiver. At this point, the resultant force is 0 because there is a force exerted upwards from the airplane that balances the skydiver's weight. So we have the weight and the force from the airplane. Here the velocity is 0 and the acceleration is also 0. Now the skydiver jumps from the plane. At this position, we only have the weight force acting on the parachutist, and the resultant force is downward. We have the velocity 0 meter per second and the acceleration is 9.8 meter per second square. Now as the skydiver starts to fall, we have air resistance added to the force. But the resultant force is still downwards because the weight is still bigger than the air resistance. We notice that the velocity increased, it's now equal to 35 meter per second, and the acceleration decreased, it is equal to 4.2 meter per second square. Now the skydiver reaches a terminal velocity, and that is when the air resistance and the weight are equal. They become balance forces, and the velocity equals 56 meter per second, and the acceleration due to the balance forces is equal to 0 meter per second square. Now, the moment the skydiver deploys the parachute, the air resistance increases, so the resultant force will be upwards, since the velocity is now equal to 41 meter per second, and the acceleration is equal to -5 meter per second square, or we can say here it is a deceleration. Now the skydiver reaches a new terminal velocity, and at this point the air resistance and the weight are equal again. The new terminal velocity is now equal to 5 meter per second, and the acceleration again is 0 meter per second squared due to the balance forces of the air resistance and the weight. Now as the skydiver lands, we have two forces acting on him, the reaction due to the surface and the weight force. Since he lands, that means he's at rest, so the velocity is 0 meter per second and the acceleration is -5 meter per second square.